Hello guys, welcome back to my YouTube channel. Today I'm going to solve day 9 problem of this month on Leetcode. Before starting, if you guys haven't subscribed my YouTube channel yet, then please go ahead and subscribe it. Now without any delay, let's get started with today's problem. So today I'm going to solve problem number 840, magic squares in a grid. Okay, so first let's read about what is magic square. Okay, so a 3 into 3 magic square is a 3 into 3 grid filled with distinct numbers from 1 to 9 such that each row, column and both the diagonals all have the same sum. Okay, so this is a definition of 3 into 3 magic square. Okay, so we have given a row into column grids of integers. How many 3 into 3 contiguous magic square subgrids are there? Okay, contiguous. Note, while a magic square can only contain numbers from 1 to 9, grid may contain numbers up to 15. Okay, so we need to remove those cases. Okay, if my grid contains numbers like 10, 11, 12, 13, 14, 15, okay, then I have to just return false. Okay, our magic square should have all the numbers from 1 to 9. Okay, all the distinct numbers from 1 to 9 only. Okay, so here let's see this example number 1. So here this is grid given to us, right? 4 3 8 4 9 5 1 9 and 2 7 6 2. Okay, so in this the following subgrid is a 3 into 3 magic square. Okay, so if I just pick this 3 into 3 subgrid, so you will see that sum of all the columns is 15. Okay, sum of all the rows is 15, right? And sum of all the diagonals is 15. Okay, so this is a magic square, 3 into 3 magic square, but this is not a magic square. See, 3 1 2 3 4 5 6. Okay, so here sum is 6, and here if you just see this 5 3 8 8 7 15. Okay, no, so our row sum should be equal to column sum, and both should be equal to our diagonal sum as well. Okay, such that each row, column and both diagonals all have the same sum. Okay, so for that is why output is 1. Okay, and we also need to pick only 3 into 3 contiguous magic square subgrids. Okay, so here see, let's say I'm going to start from this index. Okay, ij. Okay, so if I want to find this row sum, then I need to move further right in this direction. Okay, so for this cell I have to write the value of index I j plus 1. Okay, this is nothing but my cell I j plus 2. Okay, and if I want to see the sum like this, okay, then ij, then this cell is I plus 1j. Okay, this cell is I plus 2 by j. Okay, if I want to see the sum diagonally, then I have to just add all these cells. Okay, diagonal cells. Okay, so now let's move to the coding part. So first thing, inside this method we need to verify that the size of our grid should be at least 3. Okay, because we need to form 3 into 3 magic squares, right? So we need at least 3 rows and 3 columns, right? So if my number of rows is less than 3, okay, or if my number of columns is less than 3, okay, in that case I have to simply return 0, because I can't form any magic squares, right? So this is what I am doing here. Then here I am just calculating the number of rows, here I am just calculating the number of columns. Then count variable I am taking to just count the number of magic squares. Then I am running this loop. Okay, so here I am running this loop for I n less than n minus 2 and j less than n minus 2. Okay, so for number of rows less than n minus 2. So why so here see, only in this cell 0 by 0 I can form one cube, right? 3 into 3. Okay, I can't form any 3 into 3 matrix starting from this cell, right? So here total number of rows 3. Okay, and in this 3, okay, n is 3. If I subtract minus 2, then I will get 1, and my I is running for less than 1. Okay, that simply means for 0th index. Okay, so for starting from this cell only I can form my 3 into 3 matrix. Okay, that's it. Okay, that's the simple reason. Okay, that is why I'm running n minus 2 for n minus 2 for number of columns, right? So here inside this I'm checking my all elements should be distinct. Okay, this is given in problem statement. Okay, all elements should be distinct from 1 to 9. Okay, and I'm checking if this row sum is giving me true value, this column sum is giving me true value, and diagonal sum is going to give me true value. Okay, so all are giving me true value, in case if the values are equal to 15, okay, because we need to fill numbers from 1 to 9 only, right, and all the numbers should be distinct, then definitely every time I'm going to get my column sums, okay, all the column sums will be equal to 15 only, all the row sums will be equal to 15 only every time, all the diagonal sums will be equal to 15 only, okay. So if row sum 15, then it is going to give me true. If column sum is 15, then it is going to give me true. If diagonal sum is 15, it is going to give me true. And if all elements are distinct, that is simply means 1 to 9, all elements are there, then it is going to give me true. Okay, in that case I'm just incrementing the count, and in the end I'm just returning the count. Okay, so now let's see this method first, row sum. Okay, so this is the method for row sum. Okay, so here I'm just giving the starting cell values, right, in this start row and start column, nothing but the indexes. Okay, and this is just my grid data I'm passing. Okay, then we need 3 into 3, right, and inside this, see, for rows I am checking like this now. First this row, okay, then this row, then this row. So every time this j value, okay, j value is only changing every time, okay, for the particular row. Okay, then for the next row I value is changing and j values remain same. Okay, in all these rows, okay, j is remains same. Okay, if I'm in this row, then j is this. If I'm in this row, j is this. If I'm in this row, j is this. Okay, so simple. I'm just checking the row sum. Okay, I am running this loop. Start row I is less than start row plus 3, because we need 3 into 3, and incrementing I, and here I am checking the row sum. Okay, so if this row sum is equal to 15, okay, we are good. If it is equal to 15, we are good. If it is equal to 15, we are good. If it is not equal to 15, then I am returning false. Okay, then definitely I can't form my magic squares. Okay, same way for column sum I am doing. Okay, so here start row, start column indexes I am passing, grid I am passing, and then j index. Okay, because I have to check column wise. Okay, so here first I need to select this column, 0 column, 1 column, then 2 column. Okay, that is fine. So here j I am running, and inside that I am checking the column sum, and my column sum if it's not equal to 15, then I am returning false, otherwise I am returning true. Same way I have to check the diagonal sum as well. So diagonal sum, two types. Okay, this diagonal sum and this diagonal sum. Okay, both should be equal to 15. Okay, so that is why I'm calculating the sum of the primary diagonal, top left to bottom right, and this top right to bottom left. Okay, so this is how we are calculating, right? Start row, start code. See here, ij, I plus 1, j plus 1, I plus 2, j plus 2. This is what I'm doing here, right? And see next, I, j plus 2, I plus 1, j plus 1, I, j plus 2, I plus 1, j plus 1, I plus 2, j, I plus 2, j, right? So here I am calculating a diagonal sum. Okay, so both should be equal to 15, then I am returning true. Okay, that's it. So I have discussed about row sum, column sum, and diagonal sum. Okay, and here in this method I am checking the distinct elements. Okay, so here this is the method for distinct elements. So here I am passing my starting row and start column as my cell, starting cell, and grid. Okay, then I'm checking for the numbers. Okay, so here I'm creating boolean array, and by default values for all the numbers from 0 to 9 are false, right? Then I am iterating over all the values in my magic grid. Okay, in my normal grid. Okay, 3 into 3 grid, I am checking all the values. Okay, so here I am checking that particular number. If a number is less than 1 or greater than 9, then we have to simply return false. Okay, because I need numbers from 1 to 9 only. And then after that I'm checking if I have already found that number. Okay, if that number I have already found, that simply means that this number is occurring more than one time, then I'm returning false. Otherwise I'm just updating that number to true. Okay, if it is not there, then in the after that I'm just iterating over all the numbers one by one. Okay, if any number is not there, okay, if any number is not there, okay, then I'm returning false. Okay, this is a condition for missing number. Okay, and in the else part I'm just returning true. Okay, so that's it. So see, this is the method for this boolean, all elements distinct. Okay, this is the method, right? All elements distinct, then row sum method, then column sum method. Easy, right? And this is for diagonal sum method, and this is the normal. Okay, that's it. That's it. So easy code, right? Now let's run it. All the test cases has been accepted. Now let's submit it. So I hope that you guys are able to understand today's problem. If you guys still have any doubts, then please feel free to ask in comment section. Till then, keep coding, keep practicing. Meet you guys in the next video. Thank you. Bye bye.